Carrier and Carrier.com. Carrier has been a long-term sponsor of the podcast. They've made it possible very early on for us to do what we do, and they are the products that we sell day in and day out. Everything from single-stage equipment all the way up to the Green Speed Extreme, one of the most efficient products on the market today. Find out more about what Carrier has to offer and about becoming a Carrier dealer by going to Carrier.com. Field piece in the SR47 wireless refrigerant charging scale. At only 7 pounds, it still reigns as the heavyweight champion of refrigerant scales. The Field piece SR47. Refrigeration technologies, and specifically Viper wipes, the all-purpose wipe that is really amazing what it can cut through. Everything from mastic to oil, grease, tar, grime, and it's nice on the hands. Makes them nice and soft when you're done. So that way you can go home and head out a-dancing when you get back to the house. Find out more at refrigetech.com/viper-wipes. refrigetech.com/viper-wipes. FastStat at fast-stat.com. You know what a pain it is when you're trying to upgrade a thermostat and you need extra conductors and you ain't got them. Well, FastStat has several different models, some of which add a common or control wiring, and some which merely extend it. Great for adding accessories, or in the case of a system replacement, no batteries or programming required. You can find FastStat at major supply houses all across the fruited plain, and if they don't have it, you demand the manager get it. Just do the Karen thing and ask for FastStat by name. Find out more at hvacrschool.com/fast-stat. That's hvacrschool.com/fast-stat. So anytime you put something out on the internet or you write something about a topic, it can run the risk of it coming off like you're saying you're the expert in the topic. And I'm certainly not the expert in everything air conditioning. I've got some experience and I want to share what it is that I know, but I also want to curate the experience of a lot of other people. And it was kind of funny because when I hopped in the van with one of my techs, I was going to shoot a video about replacing a ductless blower. It was pretty clear that, there's some things that aren't perfect. First off, his steering wheel looks like it's about to fall off. And second of all, his van sounds like it's about to fall apart.
Right now, really?
What?
Right now, really?
Right
Already?
Now, right now, really what?
Yeah, I can see the red light.
I'm not. What, you think I'm recording?
I
really, I like your steering wheel.
Do you?
Yeah, that steering wheel cover that you have is nice. So where we headed?
Well, we're gonna go out and then we're gonna make...
Holy smoke.
Yeah.
What does that sound?
That is probably my CV joints. But when they changed the tires and the rotors, they said that was...
That's normal?
No, they just said that everything was working good. And Yoakley's, he would tell me if there was something bad.
That is true. That is true. So we get in the house and Travis starts pulling the air handler apart. And we're filming, the process of pulling the air handler apart. And then he kind of looks at me with this shocked look on his face and mouths to me basically that we forgot to turn off the disconnect. Now, of course, before we do anything else, we remove the disconnect. In a ductless system, this both depowers the outside system and the ductless air handler inside. Go ahead and wink. The point isn't to say that it's okay to forget to turn the disconnect off. The point is to say that no matter how long you've done it, no matter how much you put your stuff out there for other people to see, you're always going to make mistakes, and it's best just not to hide it. We all make mistakes. We all fail, and the best we can do is learn from it.
And now, for the man who has never been high in his life, other than in a refrigerant-filled mechanical room, Bryan Orr.
Today on the podcast, we're going to talk about compressors, specifically compressor installation and diagnosis and some of the steps that you need to take. So I want this to be pretty practical. This isn't going to be like a breakdown of the difference between scroll, rotary, centrifugal, and reciprocating compressors or something. I'm going to go specifically into diagnosing them and then replacing them, particularly in the residential and light commercial markets. All right, before we get into anything else, I want to go over a couple of, I don't want to call them retractions, but some clarifications that I want to make. One of them is kind of a retraction. The first one is one of my technicians, Travis White, pointed out to me that I had mentioned I think it was in one of the meeting episodes, that pool heat pumps, the outside coil on the pool heat pump is an evaporator. But he pointed out that there are some pool heat pumps that actually have reversing valves in them, in which case they can actually cool or heat, so that coil on the outside of that pool heater can either be a condenser or an evaporator, which is a good point. So I wanted to mention that. In the way of more of a retraction, I guess, and again, I can't say that I've personally verified this, so I need to actually do some bench tests on this, but I had Tim Bagnall sent me an email basically calling me out saying, look, you're saying to flow nitrogen to 2 psi. I think I'd mentioned that in a previous episode, and I'd also written that in a process document that I'd put out. He said he's tested it, and it has to be significantly lower than that. So he's recommending using an actual welder's gas flow gauge. There's a couple different ones that are made. Uniweld makes one that's a good quality flow gauge. And he recommends setting your nitrogen flow rate to 5 SCFM as opposed to using a PSI, even if you have the one that's made by Western Digital or whatever the name of that company is, who makes the one that you actually flip to the Brazing. He's saying that even that output's way too high. In addition to that, my brother Nathan had already told me that. He had already said that he felt like that 2 PSI was way too high and that the last joint tends to blow out when you do it that way. And Tim's question to me was, well, have you actually ever done it? And the answer is yes, I have flowed nitrogen when I've brazed in the past, but it's usually been on really large line sets, that sort of thing. We did a large refrigeration job where we flowed it, but I hadn't really done it in small residential applications commonly. And I do remember when I did do it that it was hard to get that last joint sealed. So what Tim was saying is that when you flow even lower rates than that, 5 SCFM, that you still have very, very clean inside, and then you're able to actually seal that last joint. Now, once again, I want to clarify, when you're talking about flowing nitrogen, that's not pressurizing it with nitrogen. You're not actually sealing off the system. You're just allowing nitrogen to flow through the circuit. But according to Tim, at 2 PSI, that's still high enough that it makes that last joint difficult to seal even when you're flowing it through. So we're not talking about pressurizing it. We're talking about flowing nitrogen. He's saying even well lower than 2 PSI, 5 SCFM, which is a setting that you'll see on the actual welder's flow gauge. So now that we've established that, I want to give a quick rundown of who I am, because I haven't done this in the past. But before I go into why I have any right to be talking about this, when I first got into the trade, I went to AC school, and then I was an apprentice in the field, and then I went out as a technician. But within 2 years of being a technician, I was actually tapped to train new technicians, guys who had come in green, in the basics. And the goal was to get them out doing PMs and doing startups. And so I would do 2 to 4 week classroom setting courses that I had to kind of develop my own curriculum in order to do the training. And so through that process, it was a lot of trial and error. I made a lot of mistakes. I made a lot of guys mad and said a lot of wrong things, but I learned a lot. And so I actually have a pretty good pool of past stuff that I've written and thought about to kind of tap in when I'm talking about these subjects. And so what I found is that in order to learn anything, you have to both learn it, like learn and understand the theory, and then also apply it. And so there's a lot of guys in the field nowadays who never really learned the theory, and they've always applied it, but they never really understood why. And so that doesn't give you a good basis. And so there may be guys who've been doing this 5, 10, 15 years who will still benefit from hearing some of these sort of the why behind the things that we do. But the one thing I want to be really clear about is that if you are new to the business, if you've just been to AC school, or if you're just getting out there, knowing the right terms and knowing the theory is no replacement for having done the work. You have to do the work. So after I did the training position that I had at this large company, I started my own business. And I've now been in business for myself for 11 years. I've only really been where I'm primarily out of the field for the last couple years, and I still do calls now and again in the field. And so primarily where I learned what I know today of what works and what doesn't work is through personal experience. But sometimes I will teach things that I've learned from someone else that I haven't applied as much. And I'll tend to tell you when that is the case. I don't have a ton of refrigeration experience. I have done a good amount of refrigeration, but it's not day in and day out what I've done. I've got a pretty wide range of experience, but not a lot of it in that area. Most of my experience is in residential and light commercial. I've done a lot with 80% gas furnaces, which are very different animals than the ones that a lot of you see up north with high efficiency gas furnaces. What we have are primarily open draft. We don't have sealed combustion, so I'm not used to those types of systems. So a lot of the stuff that I'll teach on those, I'm learning from others, unless I can get those of you who do that day in and day out to get on the podcast. So anyway, we're going to go ahead and get now into compressors, and this is an area that I have a lot of experience. I've replaced a lot of compressors. All right, let's first start with diagnosis of a compressor. One of the worst mistakes you can make in an air conditioning or refrigeration system is diagnosing a compressor as failed when it is not failed. Okay, so everything that we do with diagnosing a compressor, we have to isolate that it is in fact the compressor that is causing the problem. One of the most common diagnoses on a compressor, and this is the one we'll start with, is the shorted compressor. When you're testing for a shorted compressor, you must test with the compressor completely isolated from all of its circuitry. A simple way of saying that is you want to actually diagnose it directly at the terminals. If it's a case of a residential condensing unit, if you haven't opened that thing up and actually pulled the terminals off of that compressor, pulled the actual leads off of that compressor, then you cannot know if that compressor is shorted. Because if you're reading at the contactor or anywhere else, there could be a problem with the wire itself. So by eliminating all of the wiring from that compressor, now if you're new to it and you don't know which wires go where, then make sure that you mark down somewhere which wires go where, so that way when you reconnect it, you reconnect them properly. That's the only danger that you have. The other danger with pulling the terminals off is that you may loosen them, and then when you put them back on, you don't have them on snug. So make sure that when you do put them back on, that you get those terminals back on snug. But I want you pulling the actual lugs or spade connections or whatever it is that's connecting those wires to that compressor off and doing the diagnosis straight at the compressor. This next area, when you're diagnosing a shorted compressor, can be a little bit controversial, but I want to just kind of remove some of the doubt around that surrounds it. I suggest that you have a good quality MEGO meter. And the reason why I say that is because a good quality MEGO meter or a high potentiometer, a high pot, is going to do a much better job of checking for a short to ground than a typical meter. If you have a good high quality Fluke or Field Piece or something, UEI meter, something that's a really good high end one, they're going to do a pretty good job too, but they don't jack up the voltage when they're doing the ohm test the way that a MEGO meter does. So I use the simple little Supco MEGO meter. I connect one of the leads to one of the compressor terminals and the other lead directly to the compressor. Usually what I do is I just kind of scratch a little spot in the suction line and I check right there. You hold down the button and it'll give you a MEGO ohm reading. You know, it says good, bad, you know, it has a couple different readings. What we're looking for is in the bad range. We're wanting to say, look, this is shorted to ground. Now, why does that work better than a typical meter? It works a little better because it uses higher voltages than a typical meter uses. And a typical meter will often give you a false negative. So it will tell you that a compressor is not shorted when in fact it is. So in many cases, when a compressor shorts out, it actually starts with a mechanical problem. Something breaks inside there. Something happens inside that compressor. And because inside that compressor, you have these windings that are immersed in the oil and refrigerant inside that compressor. So when something breaks or bounces around in there, it can tend to short out the wires. And when those windings short out, they can create a lot of carbon. And so it creates an arc. And that carbon can act as an insulator. So when you're reading it with a 9-volt battery on your meter, you won't always read to ground, even though you do have a shorted compressor. But if you were to turn the power onto it, then you would see that it keeps tripping the breaker because it is in fact flowing to ground in a short circuit sort of way. So I'm making some assumptions here. I'm assuming that you understand what a short and open circuit is, because this is not I'm not going to go through a really basic explanation of those terms. If you don't know what those terms are, we'll cover that in future episodes, or you can just Google it. But if you have a shorted circuit, you're going to read low ohms or 0 ohms. That means a good path. We do not want a good path to ground inside that compressor. What we want to see is an infinite path, which is not what you will see if you have a very good MEGO meter, but you want to see a very high resistance path in between ground, or, you know, when I say ground, I'm talking about the suction line. You know, you're scratching the suction line. You want to see a very, very poor path in between those terminals and that suction line. And that shows that you have windings that are intact, that the insulation is in good shape and they're intact. Now, what I don't want to see you do with a MEGO meter, and this is where the dispute comes in, is use a MEGO meter, and the MEGO meter may say okay, or it may show that the compressor's failing, and then immediately tell someone they need to replace their compressor on a running system, a compressor that's running, because it's showing some winding breakdown. you really need to use a Mego meter over time. You need to check it against itself. So if you're doing a maintenance, and again, in residential, you're not typically going to do this, but theoretically, you could go there and you could see what the ohm reading is to ground one time, and then the next year you could go and check it again, and you could see if that ohm reading is starting to decrease. And if it's decreasing, that's a sign that potentially the windings are breaking down, potentially the oil has moisture in it or is becoming contaminated, breaking down. And so that's a meaningful measurement at that point. But you can't just walk up to a unit that you've never done a Mego test before. Obviously, if it's reading bad, it's bad, meaning it's got very low ohms to ground. But if it's in that middle range, you can't just say, okay, it's bad, replace the compressor. You could potentially say, look, there's some signs here that there may be something going on. We recommend installing a line dryer or something like that. And that may make sense, but you don't want to just tell people that they need new compressors just because they're reading slightly lower ohms than what you're used to seeing. That's what we're trying to prevent here. Is we don't want you selling people stuff they don't need. I mean, heaven's sakes, there's enough of that in this industry from people who are trying to do the wrong thing, let alone if you're trying to do the right thing and you're just over trusting your Mego meter. So I want to establish that. But the Mego meter is a very good tool. Now, if you have a good quality Fluke makes some great Mego meters. So if you go on our website, we have some recommended Mego meters you can look at under the truck stock section of the site. So you can review those. But you may have a very good meter that reads up well into the Mego scale, and that may be good enough. You may not need to use the Supco Mego meter or a different Mego meter. And if you're reading to ground, generally speaking, under 20 mega ohms to ground, that's a sign of a shorted compressor. Once again, you're going to know you have a shorted compressor because your breaker is going to be tripping. You're going to isolate the compressor off. Another thing I recommend doing is once the compressor is isolated, meaning there's nothing connected to it, tape off your leads and turn the power back on, obviously with the fan and everything back in place. Turn the power back on and make sure everything runs without the compressor connected. In Florida, we call this the redneck test. It shows that everything's working fine when the compressor is not connected, and it was tripping when the compressor was connected. So that kind of establishes that that's the issue. But using that Mego test also helps. Now, something I want to mention, which is a big no-no, is I see a lot of guys measuring winding to winding. So they're measuring from terminal to terminal for a short. You know, compressors tend to read very low ohm readings from terminal to terminal. That's just kind of how they are. You're not going to read really high ohms from terminal to terminal. So you'll get a lot of guys who'll take their meter, they'll read from terminal to terminal, and their meter will ring, to do the dee thing, or they'll take their Mego meter, heaven forbid, and connect terminal to terminal, and that will show a shorted compressor when you do that. Your Mego meter is not designed to go terminal to terminal. Short circuits are almost never, very, very rarely are they terminal to terminal. You check them to ground. That's how you check for a short within a compressor, is from the terminals to ground, not to each other. Okay. There are some valuable measurements you can make. Some guys will say, check from common to run and common to start, and that should be the same as between start and run. I don't know how useful that test is because honestly, the common terminal is really just a central spot in between those two. So I've never really seen that as a super valuable test. If you're wanting to identify which terminal is which, well, then obviously that is valuable. Common to run is the lowest ohm reading. Start to run is the highest ohm reading, and start to common is in the center. And so you can identify which terminal is which on a properly functioning compressor by reading ohms. But that has nothing to do with identifying a failed compressor, okay? So that's the first type of failure. That is a shorted compressor. So if you find a compressor that's reading low ohms to ground, you have a shorted compressor. And you also do the isolation test where you isolate the compressor, power everything else up, and if it doesn't trip, then you can make the assumption in addition to your own reading that yes, you have a failed compressor. Yeah, I've just seen lots of cases where guys think they've got a shorted compressor ground for whatever reason, but it ends up being a crankcase heater, it ends up being a condenser fan or a rubbed out wire. You just want to do every test possible to make sure you're not quoting a customer a compressor when it's not a compressor, okay? So those are compressor shorts. Now, before I move on, I want to just say that whenever you diagnose a shorted compressor, you should go ahead and right then run an acid test on the unit. There's different people who are going to tell you different things about acid tests, which one you should use. I like the little quick acid test that you just put over the Schrader. That's de minimis. It's allowed by the EPA. Quick actually got a exemption from the rule to just do a quick couple second test. Is that perfect? No, it's not perfect. I mean, it's just a little tiny litmus paper inside of a plastic tube, but it's better than doing no test, and it's a practical test that you can do. So when you use that little test, that will tell you, generally speaking, and we've tested it, on certain ones, it shows that it's burned out, and on others it doesn't. It's not like it's saying that everything is a burnout. And 410A and 22, we've tested them on both. And so that'll come back and say, look, this is a contaminated system. And then you can let whoever's doing the quote for the compressor know that you've got a contaminated system. And so they need to quote to do the acid protocol, which is adding suction dryers and possibly using acid inhibitors if your company wants you using those or whatever the case may be, but making sure you're going through the whole protocol so you're dealing with the acid. If you see that it's a negative, that there is no acid, then you may want to do another test again when you go to replace the compressor. But in most cases, you can assume that you don't need to add in additional suction dryers or acid inhibitors, those types of things. Okay. So if you find a shorted compressor, go ahead and do that acid test at that time. That's really something you need to be doing. The next type of failure that you see is an open winding. Okay. An open winding falls into two general categories. You have internal overload, which is an open winding that happens by design. The compressor gets too hot, and so it goes out on internal overload, shuts it off. And then you have an open winding where the winding is actually open. How you can tell the difference in general, and this isn't perfect, but if you have an internal overload issue, first of all, the compressor is usually going to be hot to touch. But in some cases, the internal overload will actually stick open. In that case, you will read an ohm reading in between run and start, and you will not read an ohm reading in between common and run and start and common. So you won't read to common, but you will read from start to run in the case of an internal overload open. And of the open winding type of circumstances, that is the most common. But there will be circumstances occasionally where you will see an open winding in between start and run. And when you see that, then you have an open compressor. Now, if that's in conjunction with shorting, where you have a tripping breaker and it's shorted to ground, well, then that's a shorted compressor first and foremost. And secondarily, it's an open winding. So it's not really a valuable test to do if you've established it's a shorted compressor. I've seen guys do this, which is why I'm mentioning it. What would happen in this case with an open compressor is the compressor's not running. Power is being applied, but it's just not doing anything. It's just sitting there. And so that would be an open winding at that point. Now, if it's out on internal overload, first of all, if it's hot to touch, well, cool it down. Use water in most cases is fine to do with the power off, and leave an ohm meter on the terminals, so between common and run, say, on ring mode. So as soon as that internal overload resets, your meter will start ringing and you know that you've got it sufficiently cooled down. So that's in most cases what you're going to find. But in the rare case that you find that a compressor is stuck, internal overload is stuck open, the compressor's cool, completely cool, and it's still not resetting, and it's open between common and run and start and common, so both to common, then in that case, you have an internal overload that's stuck open. In that case, I suggest, and this is, you don't see this a lot, but if the compressor's bone cold and the internal overload isn't resetting, I suggest shaking it around a little bit. So you can maybe tap it with a rubber mallet or, grab the suction line and shake it a little bit just to try to get that snap action disc that's not resetting, getting that kind of jarred to where it will reset. And I've actually successfully reset compressors in those circumstances. If you still have it where it's not resetting, tell the customer that the compressor is not resetting. It could reset at some point in the future in between now and replacing it, but that at this point, the only thing that can be done would be to replace it. Obviously, and if you have an internal overload, you can't get to it, and so that's your only option. But I've seen cases, and that's the reason I mentioned this, where we quote a compressor, and before we can get it put in, the internal overload resets, and now we look like we're trying to sell them snake oil. So it's good to at least have that conversation in that rare circumstance. But if it's a case where you have an open winding in between start and run, that's not an internal overload, that's an actual open winding. The compressor definitely has to be replaced. The good news in that circumstance is that rarely are you going to have an acid condition unless you additionally have a short circuit. So in most cases, you don't have to do the acid protocol. The next type of failure is poor compression. Again, you have to go through all the steps of appropriately diagnosing that it is the compressor and poor compression. I'm not going to go into all of that. But in most cases, what you see is low head pressure and high suction pressure. That's generally what you see, accompanied by low system capacity. In most cases, you're going to see low subcools, high superheats. In general, the system's just not cooling very well, and you see that, kind of telltale high suction and low head. One test that a lot of guys use in order to kind of test your compression is to try to pump the system down. If the compressor's not pumping down well, then that's also an indication that it's likely the compressor. But once you've established that you have poor compression, then you're left with replacing the compressor. But once again, better failure because you generally don't have the oil fouling or the acid that you get with burnouts. And the final type of failure that you get is a locked compressor. In a locked compressor, it's that telltale going out on internal overload, drawing high amps. So you walk up to the condenser and you hear the of that compressor trying to start up. And so obviously that's also what you'll see with a bad capacitor or a bad start kit if it has that from the factory. So you want to go through all of your tests, obviously. If the system's been off for a long period of time, then sometimes using a start kit in order to get it running is an effective way. We see this sometimes seasonally where a system hasn't run in a long time, and then it will lock just because the oil migrated in a way that causes the compressor to lock, whether it's over migration into the compressor or out of the compressor, whatever the case may be. And it results in the compressor locking. And so sometimes just using a hard start kit one time even can get it running and get the oil flowing properly. So it'll continue to work from there on, even once you remove the hard start kit. But in some cases, you have to leave the hard start kit in order to keep it working. That's not a good sign. And generally at that point in time, I will suggest to a customer that they may not have a lot longer for the system to work properly. Their days are few in most cases if the hard start kit does have to remain on in order to keep it working properly. In some cases, though, you'll run into circumstances where the compressor just will not unlock. And in those cases, you're left with replacing the compressor. Now, I will tell you, I've gone to some pretty extreme measures in order to get compressors unlocked. I'm not going to go through what all of those are, but they involve giving the compressor a mighty kick with my boot. And so you kind of want to do your due diligence just to try to get it unlocked, especially if it's been off for a while, and also just to show to the customer that you've done it, because the last thing you want is for somebody who's a little, wants to make you look like a dummy who goes out and does the little extra in order to get it unlocked. But ultimately, any compressor that's locking, it's just not a good sign. Something's going on. And Ulysses from one of the groups has pointed this out, that in many cases, because of moisture in the system, you'll actually get acids that leach out copper and brass from the system and then redeposit that inside the compressors. It's what they call copper plating. And that results in some copper being built up on the walls inside the actual bearing points and inside the compression chamber of the compressor. That can result in reduced clearances, which can also result in compressor locking. So a lot of these things, whether it be going on an internal overload because of overheating, whether it be because of poor compression, whether it be because of a locked compressor, whether it be a shorted compressor, most of these things go back to some sort of system problem, whether it's the piping wasn't done properly. So whether it's that your suction line is running liquid back to the compressor, known as slugging or flooding, and those are slightly different things, but both of them involve liquid coming back to the compressor. Whether it's high superheat resulting in high compressor temperature, whether it's high condensing temperatures, high head pressure due to dirty condenser coils, whether it's copper leaching out from the different components and being redeposited in the compressor because of acids, and that came back to not pulling a proper micronic vacuum initially, whether it's an accumulator that's not allowing oil to return back, or oil being trapped in the evaporator coil. There's a lot of things that cause these compressors to fail, and that goes the entire range. So whether it's shorted compressors, whether it's locked compressors, whether it's open compressors, whether it's out on internal overload, whether it's poor compression, those are all caused in most cases by something that wasn't done properly in the initial installation of the system. Also, flowing nitrogen, which we talked about in previous episodes, is another key factor, because if you don't flow nitrogen, you have this carbon flakes that goes to the system. They can clog up your screens, they can clog up your dryers, they can clog up your expansion valve, and then that can result in things like high superheat, which result in high condensing or high compressor head temperatures, which result in issues with your compressor. So all these things are interrelated, and you want to make sure to know up front that you're installing things properly so you don't have these issues. But now I want to go into installing a compressor, kind of the step-by-step things you need to think about when you install a compressor. So the first thing you need to know when you walk up to a compressor installation, you've got one on your truck to install, is you need to know what type of failure was diagnosed. And you need to know that, first of all, so that you know to take the proper precautions and look for things when you get the system running, but also so that you can reconfirm the diagnosis. Anytime you do any type of repair where you're going out there based on somebody else's diagnosis, you need to reconfirm it. So if they say it was a shorted compressor, you should be pulling those terminal spades off of that compressor, hooking up your Mago meter or your good quality meter from the terminals to ground and seeing what you've got. Always do that first. Okay. If it's a locked compressor, reconfirm that. Just go through all the steps to make sure you reconfirm. Then go ahead and do your acid test. It should have already been performed, but it's a good idea to do it again to make sure that you don't have acid so that you make the proper procedures. You want to make sure you have enough of the appropriate refrigerant to do the job. So especially nowadays when a lot of companies are going away from R22 to alternatives, you want to make sure you have the right refrigerant. If you have to change oils, you want to make sure that you're doing everything you need to do. Because obviously if you're changing oils, you're probably going to want to do a flush of some sort, whether it's RX11 or Pro Flush. There's a lot of products on the market. You just want to make sure that you know what refrigerant you have, what oil you need in the system, so that you're taking all the appropriate steps. I would always recommend having a new capacitor that matches the new compressor, because in some cases, the new compressor may not have the same size capacitor as the old. And even if it does, you know how often those things fail. And capacitors that fail do damage to the motors they're connected to. Those motors run hot. They go out on internal overload. So I would always suggest replacing your run capacitor on your compressor with a new one when you replace your compressor. And if you have a three-phase system, make sure to replace your three-phase capacitor. Just kidding. Make sure that you have a new suction dryer if you have to do the acid protocol of the appropriate size. Don't put in the wrong size. Make sure that it's the proper capacity for the system. Also, make sure that you have a good quality liquid line dryer of the proper capacity as well. If it's a heat pump system, make sure you have a biflow dryer. Make sure that you have test kits, acid inhibitors if your company wants you to use acid inhibitors. Make sure you have the proper fittings. Make sure you have, if you're changing plug types, always good to go ahead and put on new plug anyway. It's just a good idea to do in case, a loose connection maybe had something to do with that compressor failing. Again, it's an inexpensive part, so I generally recommend replacing the plug. But at the very least, make sure that you have the right thing, because a lot of times you go from spade connections to plugs or plugs to spades, and so just make sure you have what you need. You also want to know if the compressor's warranty and if the job is billing your COD, so that way you interact with the customer properly. If it's warranty, obviously, you need to make sure to tag it appropriately. And in all cases, you also want to seal up your compressor's discharge and suction lines when you're done. Actually braze them shut. Most supply houses won't accept them otherwise. I say always. There are some cases where they don't want you doing it. It's fine. You have to deal with your own supply houses and what they want. But in general, they want them sealed shut. Before you remove the compressor from the box, confirm, again, that it was the correct diagnosis, and then make sure that the new compressor is the proper voltage, it's the proper capacity. Check the feet, make sure that the feet alignment is going to be correct for the new one. Do all of that before you pull that thing out of the box. It's nothing worse than starting on the job and then finding out you have the wrong compressor. It's just heartbreaking. So always confirm that you have the right part before you start doing any significant work. And this is true of any part, but especially something as expensive, heavy, and pain in the butt as a compressor to install. Next, you want to remove the old compressor. So fully recover the refrigerant charge. Obviously, do that the right way. Unwire the compressor. Tape the wires away from the compressor, so that way when you're doing your brazing that you're not going to damage them. Make sure to mark them so you know which wires are which and where they go. Keep in mind that your new compressor may not be the exact same configuration as the old one, so make sure you know which one is common start and run. If the system had a factory hard start kit, you're probably going to want to go ahead and replace that factory hard start kit. If it has an aftermarket hard start kit, I would recommend removing and eliminating the aftermarket hard start kit. Again, talk to your own manager about this, but in general, that's what I would recommend. So remove the old compressor. I like the old compressor lift tool that hooks in the compressor eye so you can pull it out. There's a lot of different ways that you can do that, but ultimately, if the compressor is too heavy, make sure you get another set of hands. Don't hurt your back in doing that, especially with a lot of these tall condensers nowadays that you run into. Now, if the system has a suction accumulator, remove the accumulator and extract all the old oil from it, then blow it out. This is at the very minimum. So now, in the case of a severe burnout, I would like to have seen you ordered a new accumulator with the new compressor. And the reason for that is, first of all, that accumulator is going to have all sorts of nasty oil in it. Secondly, the accumulator always has some oil in it, but if you have an accumulator where the screen blocks up on it, it will actually fill with oil, and that will cause you to have significant issues with your compressor. And so by replacing it, you just eliminate that completely. It's very easy to replace an accumulator when you're replacing a compressor. But in the case that you don't have an accumulator, which is in most cases, and you have an accumulator in the system, or meaning you weren't sent a new accumulator to replace, and you show up and the system has an accumulator in place, I would suggest pulling that accumulator out, dumping out the oil into some sort of canister so you can dispose of it properly. That way you can see how much oil was in the accumulator. If it has an excessive amount, then you might want to go ahead and replace it in case that port and screen are plugged. If it has a normal amount, then you can go ahead and flush it and reinstall it, and then that way you have a nice clean accumulator in the new system and it's not going to cross-contaminate the system. If you're doing the acid protocol. This is also where if you use some sort of acid inhibitor, that you would go ahead and add that into the compressor crankcase. I do like Acid Scavenger. It's a product by New Calgon that I feel really comfortable with. We've used it for a long time, and we've confirmed through tests that it does do a good job. Anything that you put into the system that's not oil and refrigerant, the manufacturers are going to have a problem with. I understand that. They don't want additional things in the system that can cause damage. In the case of a severe burnout where you're replacing a compressor, though, I think the trade-off is probably beneficial to use something like Acid Scavenger. But again, talk to your manager, talk to the manufacturer of the part that you're installing, especially if it's warranty, to see what their stance is on it. And like I said, in most cases, manufacturers don't love aftermarket products being put in the system. And I'm with them in most cases, but if you know you got a bad burnout, you may want to use that. This is when you would also put in your suction dryer. In the case of a straight cool system, a suction dryer is pretty straightforward. You can put it outside the condenser, and then that way later on you can remove it just by pumping it down simply. In the case of a heat pump system, there's a trade-off. If you put the suction dryer inside the unit, in between the reversing valve and the compressor, it's better for the system because you have the suction dryer closer to the compressor. That's good. It's better because the system can run in heat or cool modes and the suction dryer is in place. It's bad because now you have to replace it and you got to recover all the charge and go in and redo this whole thing again. It's a really nasty thing to do. So your option in a heat pump is either to put it in between the reversing valve and the compressor or put it outside in the suction line, but then lock the system so it can only run in cool mode. So in most systems, that would be jumpering orange to red. So that way that reversing valve is locked in cool mode constantly, and then going back in a week or so and replacing or removing that suction line if you reconfirm with an acid test and remove it. But this is the point where you have to kind of know where you're going to install this suction line dryer. And again, on a straight cool unit, it's fine to put it outside the condenser. Again, it's better to put it closer to the compressor, especially if you have an accumulator. But if you've done the accumulator protocol, then you're pretty safe to put your suction dryer outside the condenser. This is also the point that you want to go ahead and remove any old liquid and suction dryers. Now, on some heat pump systems, they have separate heat mode and cool mode liquid line dryers. So an example would be with Train. They have a lot of these little spun dryers, and one will be for heat mode and one will be for cool mode. What I generally suggest doing is cutting those out and straight piping them. By cutting them out, you never want to sweat out line dryers to begin with, because anytime you heat a line dryer, it gives up all of that moisture and crap that's built up in it. So you always want to cut them out and then go ahead and straight pipe them. And then you can go ahead and put a heat pump dryer outside of the condenser. Generally speaking, you want to actually put it right at the air handler, so inside, right before the metering device, TXV or piston, whatever you have. So that way it protects the metering device, which is the most critical part to protect in the liquid line. And then that way you only have one component to replace in the future should it ever block up. So the general rule is whenever you're replacing any major component, you want to replace all of the line dryers. And generally, I like to see if you have factory dryers inside the condensers, go ahead and straight pipe those out of the way and put a new biflow dryer if it's a heat pump outside. When I say outside, I don't mean literally outside in the weather. I mean outside of the condensing unit. And in general, if you can, put it inside in front of the metering device so that it protects that. Okay, so you want to go ahead and put in new line dryers. If you have a suction line dryer that you want to install, now's the time to do that as well. And like we already discussed, you want to make sure that you're not confusing a discharge muffler with a liquid line dryer. I've seen guys do this time and time again. It can cause disastrous things to happen. I saw a guy lose his job due to blowing desiccant throughout the system early on in my career. And so I don't want to see you guys do this. If it's in the discharge line, which is the line between the compressor and the condenser, that is not a line dryer, that is a muffler, okay? So if you see something near the compressor, discharge line, the hot gas line, that's a muffler. Muffler is generally going to stay there. There's nothing, muffler is just a shell, just an empty shell. So it doesn't hurt for that to stay in place. You don't want to cut it out. You don't want to replace it with a liquid line dryer. It's not the liquid line, okay? So discharge line is for mufflers, not for liquid line dryers. This is also when you're going to want to go ahead and reinstall your suction accumulator if you've had it out and you dumped the oil and disposed of that properly, of course. Disposed of the oil, I mean, not the accumulator. And now this is when you want to go ahead and put the compressor in. You want to do that carefully so you don't damage your back. Make sure that you're protecting the compressor when you braze it in. So I just recommend using the old wet rag. Remember when you're brazing in compressors that they're usually copper-plated steel. So you want to be consistent with your heat. You want to get in, get the job done, and get out. I recommend using a high quality solder. So 15% silver or better, especially since the price of silver has gone down. It's not so bad anymore as it was at one point. If you want to go real crazy, you can use a flux coated rod, like a 45 or 50% silver flux coated rod. Those are amazing. And then that way, even if you did go through the copper plating, which you shouldn't, but even if you did at that point, it wouldn't be a problem. So just use good quality solder and make sure to protect the compressor from excessive heat. Obviously, we talked about flowing nitrogen. So flow your nitrogen at 5 SCFM, which is very, very, very low pressure, and it's flowing through the system. So your Schrader ports are out when you're flowing that nitrogen, and that's going to help prevent any flakes of carbon from building up inside that system. Once you have it all in place, then you want to pressurize the system with nitrogen. So put your Schraders back in. If you're going to go ahead and pull a vacuum anyway, and you have the nice Apion system with the valve remover tools, then great, do that. But then you want to pressurize the system with 100 PSI or so of nitrogen. Actually go around and do a bubble test. Use your eyes and ears first. Obviously, if you hear something hissing, then you've got an issue. But go and bubble test all of your new joints and observe any concealed areas with a mirror. I see so many new guys waste the time. They get all the way into vacuum phase, and now they're chasing leaks that they could have found if they just would have nitrogen pressurized and used a mirror with some bubbles to check for leaks beforehand. Once you've held for half an hour at least with nitrogen, now you want to go ahead and pull your vacuum. And this is where you connect your micron gauge. I recommend connecting the micron gauge as close to the system as possible. Now hear me here, because this is a fine distinction. Connect it to the system, meaning it's connected, so you don't have it connected up at the pump. Have it connected at the system, but have a line that's long enough so that way your micron gauge can be above the unit and upright above the unit. And what that does is that prevents oil from going into that micron gauge under any circumstance. So first off, have it closer to the system, not closer to the pump. Second off, have it, a little bit of hose there, so that way it's above the level of the unit so that you don't get oil running into that micron gauge. Micron gauges are extremely sensitive devices, and so if you're not careful, you'll get oil in them, and then they won't work properly, and then you got to clean them. Not hard to clean, just use a little rubbing alcohol with an eyedropper and shake them around a little bit, and that'll clean them up, but you just want to kind of prevent getting crap in them in the first place. And connecting them closer to the system is going to give you a truer reading than if you connect closer to the pump. Okay? So if you're reading consistently 500 microns in a New York second at the pump, often you do that because you're not actually pulling a good vacuum on the system, because I know the bulk of people, when they pull vacuums, they're doing it with their Schrader pins in, with small 1/4-inch lines, and what happens is you end up having a really deep vacuum at the pump and on your gauges, but not so deep of a vacuum on the system itself. So by connecting your micron gauge more on the system with like a swivel T or something, so where you're connecting, or you can even use the common port. So if you have a separate, like if you got a heat pump system, for example, you'll have a common suction port. You can connect there with your micron gauge, so it's reading from the system and not getting a false reading out of your pump, because you don't want to think that you got a nice low vacuum when you really don't. So that's when you get that thing pulled down to 500 microns or deeper. I like to see it deeper than that, but at least 500 microns. And you want to see it hold at 500 microns. You want to see it get down there and hold. And then another good thing you can do is go ahead and valve off and make sure that it doesn't rise up significantly. It's normal for it to rise a little bit because in some cases there's a little bit of moisture that's released from the oil, but you don't want to see it rise up significantly once you've valved off the pump and it's just holding the vacuum, which is another reason why you want to go ahead and connect your micron gauge to the system more than to the pump, because if you valve off the pump and it's connected on the pump, well, you're going to be reading the pump. So you want to make sure that the system itself has a nice deep vacuum that's not rising once your pump is valved off, okay? Once you've gotten into that deep vacuum, you want to check your vacuum pump oil. So you want to make sure that it's not cloudy. You want it to be crystal clear. You want to replace your vacuum pump oil regularly. I mean, technically, you're supposed to replace it after every single vacuum. I know that's not always practical, but you want to be doing it regularly. So if you're going more than once a week without changing your vacuum pump oil, then there's a problem. And I just said that to all of my technicians because I don't see vacuum pump oil disappear off the shelves the way I'd like it to. So if you're not replacing at least once a week, then you've got a problem. And the question comes up sometimes, what do you do with the oil? Well, you catch it. So you can catch it in an oil pan that you keep on your truck. You can catch it in an old cleaner jug, whatever you've got. You can catch it in there, and you can turn it in to almost any auto parts store, or most mechanics will also take it. For us, we have a mechanic right next door that has a used oil reservoir that he's okay with us dumping it in as long as we let him know we're doing it. And so you want to make sure you dispose of that old oil. But replacing your vacuum pump oil regularly is going to be a huge part of this. And compressors are an area that it's extremely important because that compressor may have failed because it had moisture contamination in it. And so if you're not watching your oil, you're not watching your micron gauge, you don't know if you fixed it this time around. And so you could be putting a new compressor back into a wet environment. All right, so next, you want to go ahead and start adding charge into the system. What I recommend is liquid charging the system by weighing in a factory charge into the liquid line. I know that it's generally not going to get all the charge into the liquid line, but you can get a good percentage of it in, and then once you start running it, you can add the rest. You never want to add liquid directly to the new compressor into the suction or discharge ports. You don't want to inject liquid refrigerant in there because it's going to foam the oil. It's going to cause issues inside that compressor. So don't add liquid into the compressor directly. Add it into the liquid line, and that way you're safe. It has to go through the metering device or all the way through the condenser before it can get to the compressor. The compressor has a crankcase heater power up the high voltage in the system so the compressor can be warmed to reduce liquid slugging on startup. So, ideally, you would have that on for a day before you run the system. I know it's not practical, but if you have one, go ahead and power up the high voltage before you power up the low voltage and let that compressor warm up. So maybe, give it 15 minutes or half an hour. Is that a huge difference? No, it's not a huge difference, but at least you're doing your due diligence. All right, so before you turn the system on, wait for the charge to equalize and the compressor to warm, then run the system with your amp clamp on the compressor common lead. So have that amp clamp on there as soon as you fire it up so that you can check and make sure that nothing's wrong. As soon as you power that thing on, this is your moment of truth. Listen for weird noises that could indicate the compressor running backwards if you miswired it or something. Make sure that your amp draws are normal. Watch your pressures right away to make sure you don't see a head pressure that's rising sky high or a suction that's diving. So just make sure that you're watching it when you power it on. I see a lot of guys go inside and turn on the thermostat and then walk outside, and the thing's been running 30 seconds, a minute before they've even looked at what's going on. It's a big no-no. There's a lot of cases, especially if you think about a three-phase unit, you could have wired something backwards and that compressor could be running backwards. And of course, in a reciprocating compressor, that doesn't matter, but in a scroll, it matters greatly. And if that's happening, you can cause damage to it if you run any amount of time running backwards. So now once you've let it run for a significant amount of time, so usually 30 minutes plus, the charge will stabilize and you can start setting in factory superheat and subcool. And that's when you want to take time, add the refrigerant in slowly. Obviously, most refrigerants nowadays you have to add in liquid phase, which means you have to make sure that you're metering it in very slowly into the suction line. If you have a heat pump, you want to check it in both heat and cool modes. Obviously, if it's really hot outside, you can't run it in heat mode very long, but you can run it long enough to make sure that it functions in heat mode and vice versa. I always recommend cleaning the drain line and drain pan as part of compressor replacement because that's just such a common fail issue, and you want to hit any common thing that can happen. When you're replacing an expensive part like a compressor, the customer wants to have that peace of mind that they're not going to have another issue anytime soon. So go through the entire system, check your evaporator coil, check your air filters, check your airflow, I call them the 5 pillars, check your air temperature split, your suction pressure, your head pressure, your subcool, and your superheat, and make sure that they're all really where they need to be. In addition to that, look at the entire system and assess any possible causes of that previous compressor to fail. So we've already addressed a lot of them. But you want to look and say, is the piping done correctly? Is the suction line properly insulated? Because, suction slugging is a real common one that people look at, slugging or flooding, where you have liquid refrigerant coming back to the compressor crankcase. But one thing that a lot of guys don't think about is that if you have high superheat due to an uninsulated suction line, that can also lead to high compressor temperatures, which can break down oil and cause problems inside the compressor. Is the superheat proper coming back to the unit? Are you seeing above a 5 superheat and below a 20 superheat coming back to the condenser? Obviously, if you have a fixed orifice system, you may have a little higher than that in some circumstances, but in most cases, that's what you want to see. So you don't have a slugging condition coming back to the compressor, and you don't have too high of superheat coming back. You want to make sure your head pressure is not too high. You want to make sure your condenser coil is clean. If you see anything on the condenser coil and you're replacing a compressor, just go ahead and clean it as part of that. If you need to charge the customer for a quote or charge or whatever, again, I don't want to tell you to do free work, but in most cases, I think your manager would be happy to know that you cleaned the condenser coil as part of replacing the compressor. At that point, once the system's run a while, you want to go ahead and do another acid test and just see where you're at. Make sure that it's not showing acid in the system, and also check for pressure drop. If you did install any suction line dryers, check for pressure drop across the suction line dryer. Make sure you don't have more than 1 to 2 psi pressure drop across that suction dryer. And again, I'm doing that off of memory, so if I got that number wrong, please tell me. It's a good idea if you installed any liquid line dryers at that point to check for a temperature drop across any liquid line dryers to make sure you don't have any issues there. If you have a system that was a burnout, then you are going to need to come back and replace or cut out the suction line dryer and straight pipe it, and definitely replace the liquid line dryer as well at that time. So if you come back a week later, do an acid test, it's clean, then go ahead, cut out the suction line dryer. Heavens, do not sweat it out, cut it out, straight pipe it, and then replace your liquid line dryer. Whether it's a heat pump, you would replace a biflow. If it's straight cool, then it would just be a typical line dryer. And then that way you can leave the system at that point. If you come back and it still has acid in it, then at that point, that's when you'd want to put in another suction line dryer and then do the whole thing over again. You want to ensure that when the customer spent, a lot of money putting in a compressor, that you're not leaving it with measurable acid inside that system. And again, I recommend the product made by Quick, but there's other products and your manager may prefer something else, and that's fine too. Mainstream makes the Mainstream Quick Check. Sporlan makes the Sporlan Test All, and that's also a great product. It's just a little more difficult to use, and you're relying on getting oil out of that system, and that can be tough to do. In some cases, it's as crazy as, cut the compressor back out or the accumulator out in order to dump some oil out, and that's just not an easy thing or practical thing to do. Obviously, in larger commercial systems where you have oil pumps and oil return systems that you can actually get some oil out of, then it's easier to do continued testing on the oil to check for acids in the oil. But, go through the entire system, make sure that the piping looks right, that if you have big differentials in height between condenser and air handler, that you have proper trapping for proper oil return. Just make sure the copper sizing is correct, that they're not reducing down to some, stupid small size or something like that. So just go through the whole 9 yards. If you're able to catch things, then great. You're the hero. You found the cause. If you don't find anything, well, that's okay too, but at least you've gone through all of the steps. Hope this was helpful to you when it comes to diagnosing and replacing compressors. If there's anything that you would add or take away out of this process, let me know.
Thank you as always, and we'll see you next time on the HVAC School Podcast.